Hello everyone, this is Algebra Skills and Geometry Foundations lesson number 1. Topics for today: describe, draw, and provide proper notation for each of the following points, line segments, lines, rays, planes, angles, collinear points, and coplanar points, as well as recognize and label congruent line segments. Let's get started. Okay, let's talk about some terms. Geometry definitions are formed by using known words or terms to describe a new word. There are 3 words in geometry that are not formally defined. These 3 undefined terms are point, line, and plane. So a point, the most basic building block of geometry, has no shape or size, only location. It's represented by a dot. Here is a point P. Here is also a point. The correct notation for labeling a point would be to write out the word point and then the letter. So this would be correct notation for point P. How about a line? A line is a straight, continuous arrangement of infinitely many points. A line has infinite length and no thickness. A line is named using what you should have here. Fill in this blank with 2 points. You only need 2 points to name a line. Any 2 points can make up a line, but it has to have at least 2 points. Here's the notation for this line seen above. Okay, if I were to add another point, let's say C, I could call this line AC, or line CA, or line BC, or line CB, with the appropriate label above it. So there's 6 different ways to name that line, as you can see here, 1, 2, and then 3 through 6 over here. All right, let's continue. All right, a plane has length and width, but no thickness. No thickness. I like to think of a plane as an infinitely wide piece of paper. It is like a flat surface that extends infinitely along its length and width. So this line right here, this part of the plane, is actually not its endpoint. It continues on forever in all directions. But we don't have the ability to sketch that. We just know that this surface is infinite in all directions, and it looks like it's labeled by P, a very fancy P there. So this would be the notation for plane P. You would write the word out, and then the letter that represents that. Okay, let's continue. Some defined terms. Definition is a statement that clarifies or explains the meaning of a word or phrase. So collinear means 2 points on the same line, actually 2 or more on the same line. As you can see, in this case, A and B and C are collinear. Okay, coplanar means points on the same plane. As we can see here, D, E, and F are coplanar. However, D, E, and F are not collinear, right? Because I can't draw a single straight line through all 3 of them. Okay, I could draw 3 separate lines containing 2 out of the 3, but I can't draw a straight line containing all 3 of those points. That is collinear and coplanar. Let's continue. A line segment consists of 2 points called the endpoints of the segment and all of the points in between. As you can see with a line segment, we have a termination of the line at points A and B. Those are endpoints. Notice on the notation, the absence of the arrows on the end of the line segment symbol on top. Okay, now a side note, if I were to write AB as opposed to AB, this represents a line segment. It's the actual object, whereas this symbol represents the distance from A to B. Okay, so if I were to write XY, this would be representative of the distance from X to Y. However, XY is the actual segment. Okay, so it's representative of the physical, tangible object. All right, so let's look at the next item here. Pay attention to the details. So if A to B is 5 centimeters, then AB is 5 centimeters. Okay, then we could say that the measure of segment AB is 5 centimeters. That's a different way to write that AB is 5 centimeters. Measure goes with objects. Okay, two objects with the same size and shape are called congruent. We can label that, let's say in this example, that segment AB is congruent in length to segment CD. We could mark that with these hash marks. These hash marks tell us that those two are the same length. Okay, now objects like lines and line segments and others that we'll come up upon are congruent to each other. Now, if they're the same length, they're congruent. Whereas distances, labeled by, let's say, AB or XY, right, with no notation above it, are equal. So distances are equal, whereas objects are congruent. Let's look at that on the next slide. Okay, so I can see that the distance from M to A is equal to the distance from T to H, and I know that because I see that they have the same measurement. Therefore, I know that the distance, these are distance symbols, will be equal. So I will take this symbol, those distances are equal, whereas the object, which is the segment MA and the segment TH, they are congruent. That's the symbol for congruence. So we've got equal or equality and congruence. As we talked about earlier, remember that distances and lengths are equal, whereas objects are considered congruent. Let's look at some more. To label that segments are congruent, mark them with the same number of hash marks. We talked about this on the previous slide. So if we know, like it said here, that the segment MA is congruent in length to the segment of TH, I would mark them with hash marks appropriately. Now I could use one hash mark instead of two as long as I have them duplicated on both objects. All right, let's continue. All right, midpoint. Midpoint is a point on a line segment that is the same distance from both ends. So the distance from T to U would be equal to the distance from U to V. Or I could say that TU, the object or the line segment, is congruent in length to VU. Okay, that's two different ways to say that. Now, if I have a midpoint in this situation, if these two are equal in length, then U is the midpoint. U, wow, is S-I-S. U is the midpoint of TV. Okay, outstanding. Let's talk about rays. Rays, one endpoint, and then goes on forever in the other direction. So here, you can see I've got ray AB. Starts at A, goes through B forever. This is one way to write it, ray AB. Here is a symbol representation, symbolic. Okay, this would be ray AB. See how A is the starting point of the ray? Then we go through the point B on forever. This is also ray AB because we have a starting point of A through B forever. As you can see here in this example below with the arrow, or the I don't know, what do you call that? Yeah, that's just an arrow. I don't have a better word for it. Okay, this ray starts at B and goes through A on forever, or it can start through B and go through C forever. However, we could not write it as the following. Don't write it like this. This is a sad face. This would not be ray CD because it doesn't start at C, right? It also could not be ray CA or ray AB, right? Those are all inappropriate notations for that ray because it does not start at A or at C. It starts at B and goes through either one of them. Now, this is unnecessary. Someone will do this, but someone will call this ray BAC, right? That's inappropriately labeled. You only need two letters in order to write a ray. So you'd use BA or you could use BC. Okay, let's continue on to the last slide. Okay, one term that we need to be aware of is the term bisect. Bisect means to cut in half. So a midpoint bisects a line segment. Here, midpoint U, if U were to be the midpoint, then it would bisect TV, okay, cutting it into two equal parts. So U bisects line segment TV. Okay, ray can also bisect an angle. So ray BC bisects angle ABD. The symbol right here is angle ABD. Therefore, ray BC, okay, let's put that in red, bisects angle ABD. Angle ABD. And therefore, what happens is we get two equal angle measures. Therefore, that means that the measure of angle ABC is equal to the measure of angle CBD. Okay, or we could say that angle ABC is congruent to angle CBD. All right, guys, that's lesson 1. We'll see you in the next video.